The Lester B. Pearson College of the Pacific uses education as a force to unite people, nations, and cultures for peace and a sustainable future. 200 students from 88 countries. They come to study the International Baccalaureate program. They leave with knowledge and attitudes that will be a force against bigotry and for building understanding between people. They also learn about the environment. The Race Rocks Environmental Reserve, established in 1980 after a proposal by the college, is operated by the students and staff.
It's a really, really rich ecosystem there. You get so many different animals. You have like hundreds of species of anemones, millions of sea stars. It's just everything is there. And then to add it all up, you get sea lions there.
Just a few weeks ago, I was driving down here, and there were sea lions all over the island. And we're down, and some of the sea lions came close to us, and it's just, oh, it's remarkable.
Race Rocks and Pearson College, the perfect place for some of her brightest young inhabitants to study Mother Earth. Almost perfect. Electrical power at Race Rocks is generated by 2 large diesel engines. The noise, emissions, and environmental risks associated with them are an affront to the spirit and mandate of the Race Rocks project.
Well, you hear the generator in the background. It's a diesel generator, essentially, that's been making that kind of noise since the early 1900s.
The diesels have to go, but for various reasons, neither wind nor solar energy are feasible sources of alternative energy for Race Rocks. Something else is needed. Clean Current Power Systems is a Canadian company based in Vancouver. Since its inception in 2001, Clean Current has developed and tested in prototype mode a bidirectional turbine generator that produces electricity efficiently from tidal currents. Renewable energy from the ocean. It's been an elusive dream for teams from around the world. The technical challenges rival those of aerospace.
I worked for Lockheed Martin for 30 years in the aerospace business, mostly building spacecraft, designing building spacecraft. Space is fairly benign other than temperature excursions. Underwater, it's highly corrosive. Even stainless steel would dissolve in time in salt water.
The turbine generator prototype worked. Then it was time to test it in the real world, in a harsh marine environment, over an extended period of time.
Then we needed to find a place to put it. And that sounds easy, but we needed a place with ferocious currents, but we also needed a place that wanted us.
Clean Current had the technology. Pearson College had the need.
Our group approached them with a design for their energy problem out here. They were very intrigued and interested. So very quickly BC Parks came on board, Department of Fisheries and Oceans also came on side, and within 6 months we had all the regulatory approvals required to actually kick up a project. And from there we just got our partners together and we're really up and running.
But paradoxically, Clean Current had reached a point at which, all too often, promising technologies die or are forced to leave Canada.
You can be at a point in the development of your technology where you say, right, we've proved the concept, we've got a design, we're ready to go, but we need that bump in money. We need someone to come in, stand behind us, and give us that push into the next phase. Because we have to do that next phase, otherwise the commercialization dream, as real as it seems to us, is just not going to be a reality.
The money we found within Canada's Environmental Innovation Fund.
Every day in our natural gas and our crude oil business, we experiment with new technologies and new processes. In fact, we have a continuum of projects from small-scale pilots to large-scale commercial developments. What we're doing with the Canada Environmental Innovation Fund is helping companies that have a new technology with their first pilot project. In the real world, funding that critical demonstration phase is difficult, and we feel we're removing an obstacle to a more rapid commercialization of innovative environmental technologies.
The project also received financial support from Sustainable Development Technology Canada, a not-for-profit foundation created by the Government of Canada that supports the development and demonstration of clean technologies.
It's a common problem for Canadian entrepreneurs not to be able to obtain funding or support at the development and demonstration phase because the technical risks are too high and the financial returns too low for most private sector investors to participate. To ensure that Canadian innovation successfully enters the marketplace, where profits are realized and where the Canadian public at large receives environmental benefits, we must bridge the gap in the innovation chain, which SDTC is uniquely mandated to do. Attaining a win for homegrown technologies, such as this progressive renewable energy supply option developed by Clean Current, is vital if the Canadian economy is to become both more productive and more competitive, both domestically and internationally.
With the funding in place, Clean Current is ready to tackle the difficult challenge of creating reliable, clean electrical power from the sea. The test will occur beneath the surface 100 meters from Great Race Rocks Island in about 15 meters of water. The turbine will be anchored to the seabed and generate electricity as it rotates with the force of the tidal currents. It works when the currents are flowing in either direction. Electricity will travel in a buried cable along the seabed and up onto land. Any impact of the new technology on the environment will be carefully monitored and reported to BC Parks as part of the permit process. After receiving regulatory approval and funding from MCANA and SDTC, Clean Current buckled down to an intense 6-month design phase.
And there's some really big engineering challenges that we're just starting to get a feel for right now as we start to go into the process of selecting coatings for anti-fouling and those sort of things. So
it's really tough to make a blade that's bidirectional. Every prop on a boat or an airplane is one directional. So we had to come up with an unusual blade structure. What we built is a set of samples that were coated with different materials first and then different coatings. We have them underwater out at Pearson College right now at Race Rocks. We pull them up and check.
For every problem, a solution was found, and every solution led to new challenges.
And the more that we study the turbine and the more we study the generator, the more the pieces of the puzzle kind of fall in place.
We're having a lot of fun doing a building now, but it'll be super exciting to see this thing working.
There were no out-of-the-box solutions, only out-of-the-box thinking. Once the turbine was ready, it was time to get it out of the shop and on its way to Race Rocks.
We have to build a service vessel to be able to raise and lower it onto that pile. So right now at a shipyard in Vancouver, the service vessel is being built, and then we'll put it on our service vessel, and then the tug will push it over here.
November 29, 2005, a big day at Race Rocks. The barge moves into place to drill the sockets for the lower pile, upon which the generator will rest. Minutes into the operation, disaster strikes.
Basically, the crew came out here on a reasonably looking good day in November, it was late November, and they went out to the site and tried to put down, the barge came into position, lowered down 2 posts, which are called spuds, and immediately bent one of them.
By the time a replacement was shipped from Vancouver the next day, the weather had changed. The window of opportunity closed and drilling delayed until summer. The crew went home.
Nobody said this was going to be easy.
But work went on at the Clean Current facility in Vancouver. The team continued to innovate to meet every challenge head on.
We have great days and we have days that you just want to wish you never got up. But the team's doing well, especially now when everything is coming together. The mood is very buoyant right now. We'll be successful next time.
July 2006. After 3 costly weeks of frustration and delays due to weather and technology, drilling is successful. The posts are installed, the cables laid, and the site at Race Rocks is finally ready for the installation of the tidal generator.
Well, we're making history today. The turbine is finally going to be put on its foundation in the waters around Race Rocks. we'll be witnessing some real emotions in another hour or so, but it's going to run the gamut because many people have worked very hard and have really been passionate about this project. And you know, it's like any project, it's had some major challenges, but these folks have stayed with it. They believe in this, and it's going to be very, very sweet when they see it be installed and go under the water.
And those cables go down with it to guide it into position. But there's also divers down there. They're basically our eyes down there, telling us, okay, it's going down. It's maybe 5 feet to the left or 6 feet to the right. The unit went down relatively easily. Yes, it was finally in the water, and we were finally seeing our dream come true.
Following installation, the Tidal generator is run through a series of rigorous tests, passing each with flying colors. When the lights come on at Race Rock, lights will go on around the world, because a small band of people really can change the world.
We spend a lot of time really talking about how can we be better citizens, how can we be more sustainable, and yet here we are actually doing something concrete.
I hope that this just proves that what people have been believing all along, that we can really have a sustainable future.
And it proves the power of a great partnership. Race Rocks, a tidal energy project by Clean Current Power Systems, the Lester B. Pearson College of the Pacific, Encana Corporation, and Sustainable Development Technology Canada.